Yeah, thanks, Andy, and welcome everyone to Spark Summit 2015. It's great to see everyone here, and we'll have a fantastic program for you. So Patrick and I are going to start by talking about what's been happening in the Spark community in the past year, and there's been a lot of stuff going on, and we just want to recap some of the highlights and some of the things that have gone into Spark in the past few releases. So in summary, in a nutshell, this past 12 months has been a fantastic year for Spark, the highest year of activity ever, and a year with some really large milestones being hit by the project. At the beginning of the year, actually, last year, Spark had actually become the most active open source project in data processing in general, big data, small data, and so on, which is sort of a fantastic feat, and it shows that there's a lot of excitement in building new technology for this kind of large-scale data processing. And throughout the year, it has remained the most active project in the space. This year, we added a new programming language to Spark, namely R, which we'll talk about later, that opens it up, again, to a brand new class of users who can now begin taking advantage of it. And we also added many new features and community projects around Spark that continue to grow the ecosystem. So I'll start with a few numbers comparing the community to this year versus last year. So last year at the Spark Summit in June, we did some counts of different metrics in the community, and we saw at that point the Spark project had 255 contributors since the beginning of the project. There were around 75 people active each month, actually sending patches, and in total there were about 175,000 lines of code. And this was already fantastic growth compared to the year before. It was more than doubled. And we were very curious whether this would continue. So this year, the growth has actually continued and in some respects accelerated. In terms of total contributors, right now we have more than 730 people who've submitted code and gotten it merged into Spark. This means that about 2/3 of Spark contributors are new this year. And if we're on track, we will hopefully hit 1,000 by the end of the year. Contributors per month is almost double. It's been 135 in the past few months. And in terms of code, it's also more than doubled. We have now 400,000 lines of code in the Apache Spark project. Now, if you're wondering where the code goes to, is it like making this one engine super complicated? That's actually not the case. Most of the code is going into the libraries built on top of the core engine, although there is some exciting stuff happening in the core engine as well, which we'll talk about. But in terms of libraries, for example, the machine learning library has quadrupled in size in the past year, so has Spark SQL. So this is where a lot of the activity is. In terms of, beyond the development community, there's also wide commercial use and actually commercialization of Spark. So in terms of users, we've counted at Databricks over 1,000 companies using Spark, and I've put up the logos of some of the companies that will be presenting at this Spark Summit or presented at the one in New York 2 months ago. And the cool thing is we see Spark being used and being talked about in a very wide range of industries, well beyond the sort of web companies that initially began using this kind of technology. So we have everything from banks, auto manufacturers, and so on, biotech, and so on. And you'll see some pretty exciting talks from these. In terms of distributors and applications, we've been working to build commercial services around Spark at Databricks for 2 years, and we've been joined by a wide range of other companies, including all the Hadoop distributors who began supporting Spark last year, most large companies in enterprise data, most companies in business intelligence as well are building connectors to Spark. The other thing that we've seen this year that's exciting is more publicly presented large-scale use cases. So people talking about some of the largest scale Spark clusters and applications that they have. So some things that came out this year, first of all, the largest Spark cluster that we've seen discussed publicly is an 8,000 node cluster at Tencent in China. If you're not familiar with Tencent, it's a social network company in China, and it has essentially a billion users, basically everyone in China. So it's actually much larger scale than many of the social networks you see in English, for example, and they need a lot of computational power to deal with that scale. In terms of largest individual Spark jobs, we've seen several jobs published that are more than 1 petabyte. So one is an image processing workload at Alibaba. They ran a job on 1 petabyte of data over a course of a week to do very heavy sort of number crunching on these images. And also at Databricks, we've used Spark to sort 1 petabyte of data. This was more benchmarking and showing that the engine can send that much data across the network. In terms of streaming, I've been trying to find the largest streaming intake, and the biggest one I found is over 1 terabyte per hour of streaming data. And this is at Janelia Farm, which is a research institution in neuroscience. So they use Spark to process images coming from basically imaging of the brain, and they get more than 1 terabyte per hour of these images, and they do various transformations on them to make sense of them in real time. And this one actually is only about 30 or 40 machines, so I'm sure this kind of use case can also scale up. And finally, Spark also set the 2014 record for on-disk data sorting, which we helped set at Databricks. And it's just a testament to sort of all the work that's gone into the engine to make it fast. Apart from the engine itself, Spark also lives inside an ecosystem, and we've seen a lot of great connections with other open source projects and applications built on top. So first, in terms of applications on top, we have Hive, Pig, Mahout, Scoop, and many of the projects in the Hadoop ecosystem are now connecting to Spark as a backend engine as well, so that they can take advantage of all the things going on into it. And there are also quite a few new projects built directly on Spark that anyone can use. In terms of deploying Spark, there are now connectors to many different deployment environments: Hadoop, Yarn, Mesos. Most of the new sort of container-based environments coming around come with a way to launch Spark to make it easy to deploy. And finally, in terms of data sources, we've seen integration with tens of data sources, most open source key value stores, file systems, and so on, you can see are building some kind of integration with Spark. So let me step back now and look at, okay, what is the Spark project trying to achieve, and what have we actually been working on in the past year? So if you look at Spark, these are kind of the components in there today. Basically, it's this core engine, and it's unique in trying to build a unified engine that can work for many different data processing workloads and environments to let you combine these workloads as if they were libraries. So in the same application, you can combine SQL, you can combine stream processing, machine learning, and so on. And the reason that's really valuable is because real applications do combine many of these, and normally it's very complex to do that, unless they've been designed to work well together. So on top of the core engine, we have also invested a ton, obviously, in standard libraries, including SQL, streaming, machine learning, and graphs. So for 2015, at the beginning of the year, we announced at Databricks 2 big initiatives that we were working on with the community. And these were data science and platform APIs. So for data science, we wanted to not just have these great, built-in libraries targeted mostly at software engineers, but we also wanted to provide the high-level interfaces that people use for working with small data on a single machine, and give you the same interface and let you run it on a cluster, because this would open up Spark to a much wider community of users. So this has been the data science direction. And in terms of platform APIs, we saw all these connectors to Spark coming along, and we wanted to have a very standard ways for people to plug things in that will continue working with Spark in the future so that we can grow the ecosystem. So let me just recap some of the things that happen in data science. These are all out now. So for data science, we've had 3 things come out already this year. First of all, data frames, which are a very popular API for data transformation in Python and R. And now you can run essentially the same API on a Spark cluster. Second, machine learning pipelines, a much higher level API for machine learning inspired by scikit-learn that makes it very straightforward to build a complete machine learning workflow. And finally, the R language support, which is coming in Spark 1.4, and which Patrick will also talk a little bit about. In terms of platform APIs, there have been 2 big efforts that came out already. The first is data sources. So this is a uniform interface to different data sources in Spark, which lets you access whether your data is, say, in Hive or in JSON or in Parquet or in MongoDB or any of these data sources. You access it in the same way through data frames or through SQL queries. So it's very easy to take your application and combine and move it across many different data sources. The second thing that we've put together is Spark Packages, a community website for listing packages that work with Spark that already has over 70 packages. And it also comes with a way to very easily launch, add these packages to your Spark shell when you just launch Spark. Finally, apart from these 2 things, there are also continuous improvements happening in the engine itself. And one of the big ones that you'll hear about at this conference is Project Tungsten, which is an effort to bring Spark closer to bare metal, to use code generation to run the fastest possible code in order to execute your programs, binary processing of the data without having to represent it as Java objects, and off-heap memory management, and also new types of hardware such as GPUs and SSDs. So there'll be some great talks about this tomorrow. And we also continue to work on visualization, debugging all these tools to make Spark easier to use. So that's been a little summary of the things that have been going on in the past year. To give a bit more detail, I'm going to invite Patrick Wendell to talk about the recent Spark 1.4 release. Patrick is a co-founder of Databricks, where he leads the Spark development team, and he also was the release manager for Spark 1.4. So he's the perfect person to talk to you about this.
Thanks, Patrick. Patrick? Hi, everyone. Thanks for the introduction, Matei. It's great to be here. This is a completely packed house with folks standing on the side, and that's such a treat for us, given that the first Spark Summit was not that long ago with a much smaller crowd. So seeing the growth of the community is really inspiring. I'm here to talk a little bit about Spark's 1.4 release. This release is actually currently available. We shipped it last week. You can go and download it today on your laptop if you want. Of course, I don't have time to talk about everything in this release because there are so many cool features and new things being added to Spark all the time. But I'm going to highlight a few themes from the release that might be interesting jumping off points for you in this conference as you look at which other talks you want to go to and what you want to learn more about. To give some numbers on this release, it's the work of more than 230 developers. So it's a lot of people writing code for Spark. And I counted up all the companies. There's more than 75. At that point, I stopped counting. So definitely a community effort from many, many different companies. So the biggest feature in this release is that for the first time since about 2012, when we added the Python API in Spark, we've added a new first-class language API for the R language. For those who aren't familiar with R is a language that is targeted and developed by really statisticians, data scientists, and mathematicians for being able to point this language quickly at a new data set, slice and dice, extract columns, and do statistical processing on it, model building, and so forth. And the reason why R is interesting to us in the Spark project is because it's seen this sort of exponential increase in use across the broader programming language ecosystem. So this graph shows a very popular sort of index ranking for programming languages in the last 7 or 8 years for R. And as you've seen, there's this kind of hockey stick growth as there's broader interest in data science overall. Correspondingly, R is getting a lot of attention. The Spark R project was actually started in the AMP lab. The grad student who leads the project is giving a talk at this conference, which I encourage you to check out. And with the work of both the AMP lab, Databricks, Alteryx, Intel, and a few other companies, we've made this kind of production ready and put it in Spark 1.4. Now, for those who've seen R before, the core abstraction is something called a data frame. It makes it really easy to do different types of statistics analysis on data. And the Spark R release uses Spark's own data frame API, which was announced a few releases ago in Spark, and largely inspired by R. So it's a very natural thing to now add an R API for R users. So the great thing about Spark R is that R users get all the benefits of Spark's runtime, which address actually some weaknesses in the kind of default R runtime. So for those who use R, you'll know that it has some issues scaling to very large data sets. It's not really a multi-core runtime, and it certainly cannot operate across many machines. So what Spark R users get sort of for free is all of the internal engineering we've done in Spark around distributing data and dealing with massive scale, fault tolerance, and these other sort of pretty difficult challenges. And that includes a lot of optimizations we do, things to place data in a nice way across a cluster, to avoid I/O when we're touching data sources and so forth. You get this all sort of out of the box, and you're not even using a Java language, you're using R. What's also cool about the way we built this, which will be discussed more in the keynote tomorrow, is that you don't pay any performance costs for using R compared with the like sort of native Scala and Python APIs in Spark. So it has performance parity. And the last thing I'll mention about Spark R is that you also get access to all of the input-output libraries, which Matei mentioned briefly, that we've built into Spark. So here's a few examples of creating an R data frame from, for instance, a JSON file. Well, we have really nice JSON support in Spark. You can just point Spark at a JSON piece of JSON data. We'll analyze it, figure out what the field names are. You don't need to do any manual parsing. You get all of that in R for free. And similar for other data sources we've implemented, like the ability to connect to a JDBC ODBC database, the ability to read from a Hive table in a Hadoop environment. This is a lot of engineering effort that's gone through, and all of the new Spark APIs, in particular R, get the benefit of this. There's also several external versions of this because we've made it a public API that other people can implement for sort of smart data access into Spark. So if Spark R is about interactive exploration for data scientists, the next feature I'm going to talk about has to do with taking that exploration, cutting the human out of the loop, and making it into a production pipeline. And that's the machine learning pipelines feature that has had pieces come in earlier versions of Spark, but is fully graduating in the Spark 1.4 release as a stable API. To give a little bit of background on ML pipelines, this is based on the following observation we had when working with companies doing large-scale machine learning on Spark. In most cases, what they needed out of a production machine learning pipeline was not to just call a single algorithm in isolation. It was to do some ETL to mix and blend data sources, to do some feature engineering to extract mathematical features out of underlying data, to maybe train multiple models and choose the best one, and then to use those models to do something like prediction or classification downstream. And the ML Pipelines API, which is also inspired by scikit-learn and the ML-based project out of the AMP lab, is designed to provide really nice first-class support for doing this in Spark. So I'll give a really quick example. Won't walk through too many details, but this is actual Python code for writing a very short ML machine learning pipeline in Spark that tokenizes an input, so splits it up into individual words, does a hashing transformation to reduce the state space over words, and then does a logistic regression to learn labels based on a combination of words that are seen in an input. You can then take that pipeline as a reusable component and apply it to inputs and outputs. So now I'm training some data, and I'm predicting on some new data and outputting a result. There's an entire talk on this feature in this conference as well by Joseph Bradley, so I'd recommend checking that out if you're interested in ML pipelines. A couple more words on this. What it means for this to graduate as a stable feature in Spark is that we are locking the API. Developers can write code against this and know that it won't change. And that even applies to third-party components of pipelines. So we've designed it in a way where third parties can write pipeline components, and then any Spark user can take advantage of those, use them in their own pipelines, and contribute back things that they've worked on. We also, as part of launching this as a stable, graduated feature, we added a bunch of new utilities around feature engineering, and several new algorithms now have a pipeline component. Finally, I'll just mention on the last slide, the example I gave was in Python. Well, another part of this graduating was that the Python API is now much, much closer in parity to the Java and Scala APIs. So this is a cool new feature, and we've gotten a lot of positive feedback on it from versions of it in the last few releases, and we're really excited to kind of ship it for real in Spark 1.4. So the next thing I'm going to talk about is a lower level initiative that is not exclusive to data science and machine learning. It's actually a broad re-architecting of some of Spark's internals that will benefit all users of Spark, whether it be Spark SQL for ad hoc analytics, machine learning, as we said before, that will benefit from this as well, Spark Streaming, and the core kind of ETL APIs in Spark. And this is something called Project Tungsten. If any of you have been following from the Databricks blog, we announced this kind of major initiative we're contributing to about a month ago, and it will be a theme throughout the next few releases. In Spark 1.4, we get the first pieces of this. So we do some off-heap, totally managed memory in certain cases when we're doing aggregations. This is like a really internal core component of Spark. And what that means is we don't have to deal with any Java garbage collection or a lot of the overheads associated with the way that Java lays out memory. We do sort of fully managed memory. It's a very ambitious project, and I'd recommend checking out Josh Rosen's talk tomorrow, or there's another keynote that really dives deep into this tomorrow in the morning if you're interested in learning about this particular initiative. This graph shows a customer pipeline of ours at Databricks that, without any modification, saw a significant speed up between 1.3 and 1.4. Although, as I said, I think the real wins from this will come in the next release of Spark, which is 3 months down the road. So that's a good way to segue into what I'd like to tease a little bit, which is what's coming in Spark 1.5 and what are some of the things, at least from Databricks' perspective, that we are keeping track of on the short-term roadmap. So I just mentioned Project Tungsten. As I said before, a lot of the heavy lifting from that will really ship in Spark 1.5. Everything will be turned on by default, and we're hoping users will see a pretty massive performance improvement. Now that Spark is used by so many people, there's a lot of incentives for us as the kind of architects to go and make things run really quickly underneath. Spark Streaming, which I didn't get to mention in this talk much, but there is a full talk about Spark Streaming at this conference. Some features coming there are flow control, so the ability to better deal with bursty upstream and downstream producers and consumers in streaming sort of real-time systems. That's a very complex problem, and we'll be adding some nice features to dynamically adjust flow control in this release, and also optimizing some of the key primitives for doing state management. That's the kind of main abstraction we have in Spark Streaming, is the ability to keep track of counters and other things on incoming data, so we're going to make that all much more efficient. In the machine learning library I just talked about, we have a couple cool things coming up in the next release. One is that we're going to really nicely call into single machine solver. So that's like directly calling into things like scikit-learn when the data set is small enough that a single machine solver can take care of it, or when we're doing kind of parallel, embarrassingly parallel training of models. We're also looking at scalability here, especially around, it's not so much data size, which Spark does really well on, but in the machine learning domain, scaling to having many, many different features that you're trying to use to learn attributes of incoming data. And lastly, the Spark R API that I mentioned, well, a very natural next step there is to help really make nice bindings between Spark R and our machine learning capabilities, since I mentioned that R is extremely popular amongst data science and statistics communities. So this is a couple things on the roadmap. There's a lot more going on, but these are some that I thought I would call out. I hope that gave you some idea of what you might want to look more into at this conference and a little bit of a sense of the heartbeat of Spark and how things are going. I'd love to invite you to join us at office hours. This is Databricks office hours at our booth, and we'll have many of the kind of committers and other people working on different Spark components there to just answer your questions or accept feedback or really anything you want to talk about. There's also more coming tomorrow. I think my colleague Ronald Chin will have the schedule tomorrow in his keynote. But please stop by and join us. You get a chance to talk to some of the people working on Spark. So that's all I had for this talk. Hopefully it gave you a sense of what's going on with Spark. Thanks again, everyone, for being here. It's great to be here with the full house, and I really appreciate it. Thank you.